This is the solution or a solution for the LeetCode 3-sum closest problem with one additional constraint. So just to go over that, given an array of unsorted numbers and a target number, we're looking for a triplet in the array which the sum of those three numbers is as close to our target number as possible. And we want to return the sum of those of that triplet. But if we encounter another triplet that is equal, like if there are multiple triplets that satisfy that are the closest, say for example we have a target of 2 and one of our sums is 3 and another is 1, the difference between those two sums and our target is both 1, but we want to return the sum that is the least sum, so we would return 1. So yeah, let's just go over the plan to solve this. Basically, we want to be using the 2-pointer technique. I'll leave some resources on that in the description if you'd like. Yeah, so first we're going to sort the array and take advantage of the properties of a sorted array, the guarantees. We're going to instantiate our variables that we need, so our answer or a sum and our answer's difference. So basically that will set to infinity or some number that is so large we will never encounter a difference or closeness to the target that will equal that difference. Yeah, and then we want to, so we're iterating through our array up until the third to last element of the array, because we want to leave those last two elements for our pointers for the 2-pointer technique. And at each iteration, we want to check if there's any duplicates. So we want to make sure that the current element and the previous elements are different. If they are the same, then we would just want to continue iterating I. And then we want to get the current sum. So first we want to instantiate our 2 pointers, our left and right pointer. And I'm calling them the left and right pointer because after I, so we're iterating I through the array, and all the elements that are left form a sort of subarray. And so we always start the left and right pointer on the very left hand side of that subarray and the very far right. So the left pointer will always be I plus 1, and then the right pointer will always be the length of the array minus 1, the last element of the array. That's at least where they will start. So we want to start looping while the left pointer is less than the right pointer. So basically, while we have elements left in our subarray to check to form our triplet. So once we do that, we want to get the current sum and the current difference, or the current closeness to the target of our sum. So our sum is going to be the elements at I, our left pointer and right pointer. So we just add those three together, and that's our current sum. And our current difference is the absolute value of the target minus our sum. So we need to take the absolute value because our sum can be negative. Yeah, so once we do that, if our current difference is less than our running answer difference or closeness to the target, then we want to replace our answer, which is our current sum, and we want to replace that answer's corresponding difference or closeness to the target. So and then we also want to satisfy the condition where we have, 2 triplets that are the same closeness to the target, but, have different sums. And we want to return the lesser sum. So basically, if our current difference is equal to our running answer's difference or closeness to the target, then we want to just essentially replace it if our sum is less. And then if it is greater, then we just want to continue. And after that, we will check essentially if we have an answer, and then whether we need to increment or decrement our left and right pointers, essentially doing the 2-pointer technique. So if our, so we know, so first we're going to check if we have like an answer. If our sum is equal to the target, then we want to return our current sum because we've found our answer. And then we want to check if our sum is greater than the target. And if it is greater than the target, we know since the array is sorted that we want to decrement the right pointer, essentially reducing that subarray, the size of it. And then if our current sum is less than the target, we know that we need to increment the left side because the array is sorted. And then we just continue until, the left pointer is equal or greater than the right pointer. And then we just need to adjust our I, or increment I, and form a new subarray to use the 2-pointer technique on. So yeah, we keep doing that until we have our answer. So let's just go through the code and look at that. Sorting the array, instantiating our answer and our answer's corresponding difference or closeness to the target. So we're using 0 because basically if you do like var answer int, and you don't set the value equal to anything, Go is setting it equal to 0 anyway. So, yeah. And then we're using the maximum value for as our answers like corresponding difference to start out with, because we know that given the constraints, we know that, or at least I was guessing, that we would not have a difference that would come close to the maximum value for an int. So yeah, we're iterating through the array up until the third to last element in the array. And then we are checking for duplicates here. We instantiate our left and right pointer. We start our 2-pointer technique while the left pointer is less than the right pointer. We grab our current sum and we find the difference or the closeness of our current sum to the target. And then we check if we need to replace our current answer, both of those conditions. And then if our sum is equal to the target, we return it because we found our answer. And then if our sum is greater, then we decrement the right pointer, increment the left pointer if it's less. And then, yeah, and then there's a little absolute value helper function. So yeah, we've got a few, there's a few test cases here. You can run these tests. And then I've also included the solution in Python as well. So yeah, thanks. On to the next one.